Hello. JDBC architecture. What JDBC driver is and what are the different type of drivers in the JDBC, and then we will try to explore basic JDBC API which are used for writing JDBC applications. So first of all, let's see what database architecture means. If we talk about architecture, we talk about the kind of solution we are going to provide to particular application, and we step further, we talk about what actually the category of application is. For example, let's say if I am going to develop an application to generate the report of the student of a particular month, then definitely this particular application is not having a very large complexity involved in it, as well as it is not having requirement of complex operations, that is requirement of distributed application, requirement of client server approach, requirement of some additional infrastructure to communicate from client to server. So it is having a very basic requirement that you are having a database. In that database you are storing the relevant information, that is information related to a student as well as his or her attendance, and then you are retrieving that information, you are generating a report. This is very simple application. Now if the same application I try to develop for all the students of IGNOU, you are fully aware of IGNOU structure. It is having decentralized approach that students are at their respective street center attending the attendance or attending the classes and giving their attendance. Their attendance timing and duration is different. Their number in different classes is different. It's all vary from one location to another location. Now if in this scenario I try to develop one application, and in that application I look that just by sitting while in this studio I will get the report, then application is entirely different. Now the scenario is entirely changed. It is not the previous scenario in that I was looking for the attendance of a month of the student attending a particular class. I am looking attendance of a month, maybe the student attending a particular course counseling, but the situation is different in the sense that they are attending the course counseling on entirely different date, different time, different location, different class. Even the number of student in a particular class is different. So these all things are providing a different scenario to the new development. Now in this scenario, if I try to develop the application, what I have to do? I have to provide such a system in that every class conducted in the respective study center or regional center or the centers where students are going to attend the classes must have facility to put the attendance at their own end, and that particular attendance to be updated to some centralized place, and from that centralized place I have to pick up the information and I have to generate the report. So here is a cycle. In that cycle what you are getting? Different aspects you are getting, and those different aspects are interacting to some other aspect. So in this way you are generating different layers. So if those different layers you are generating, and that layers are generated by which driving force? The driving force is the kind of application you are going to develop or you are looking for. So your application design entirely depend on the complexity of the problem, the nature of the problem which you are going to solve. So in that respect, basically we see that our applications belongs to 2-tier type of application, 3-tier type of application, and n-tier type of application. So let us see these 3 different type of architecture for database application, that is 2-tier application. So in this 2-tier application, what you are having? Client connects directly to the server. So if a particular client is going to be connected to the server directly, for example by using your HTTP, HTTPS or email, different email protocols. So client is there, server is there, client is interacting to the server. So this particular is definitely looking very simple. Client side is scripting, offload work onto the client. So what actually you are doing is that if you are at client side, so whatsoever scripting you are doing at the client side application, on the basis of that the workload will be shared by the server. Means server is almost entirely responsible for performing the operation and then communicating to the client. One more aspect may be that you are having one application, in that some part you are running at your client end and some other part you are running at your server end. So there is no intermediate part. So disadvantage is that client get fat. Get fat means here that client is having more load, and inflexibility is there, that you are not having flexibility to have more interaction or not having flexibility to get operation distributed. So definitely these are disadvantages, but these disadvantages comes into existence only if your application belong to some other category and you are trying to implement that application in a 2-tier architecture application. Now let us see 3-tier architecture. In this 3-tier architecture, if you talk about, you are having your client side, then application run on the server side, and that particular is between your client and database. If I say client is here, database is here, then server comes in between and server is performing some operation. So client will request to server, in turn server will communicate to database, database will communicate to server, and then server will come to the client. So there is one intermediate layer in between. So this particular architecture turn up into a 3-tier architecture. Now advantage of this particular is that it is flexible. Flexible in the sense that if you are incorporating one intermediate layer between client and server, so you are providing opportunity to make modification on any layer without affecting the other layer too much. And if I say database, I am removing, there is no need to inform the client that database is being removed, just you have to modify the application which is interacting to the database at the server level. And it provides very specialized facility, that presentation is at the client level, business logic is at database level, and data management is at database level. So presentation your client, business logic is your server, and then database is your data management. And one more advantage you can incorporate in between, that you can put certain queries in cache memory, and that cache memory will provide you faster execution or will speed up the process as per need. And security aspect also you can implement with the help of the implementation of proxies and firewalls. So 3-tier architecture is basically a very genuine architecture for the application which are client server type of application. So if you talk about web application in which you have to interact with the database, or in which you are looking for some dynamic resource generation, or in which you are looking for some dynamic processing, so on those kind of application 3-tier architecture suits to the requirement. So in that, basically one very popular design pattern, or you can say a very popular model of development, is that is model view control approach, MVC model of application development. Basically this model of application development is for web application development, and it is very much suited to your 3-tier architecture model of development. That is, you are having a view, that is your client, you are having a controller, that is your server, and you are having a model, that is your database management system, and your view definitely is interacting to the server only, and server in turn is interacting to the database, and it is giving the result. Now if we look for the disadvantages of this 3-tier architecture, is that complexity is definitely higher, and complexity is higher because of that now you are having clients at different locations. Those all clients are interacting to the server, and server in turn is interacting to the database and performing the operation. So client management is one aspect involved, session management is another aspect involved, and other security aspects of identification and other things comes into existence, firewall implementation and some other security checks. So due to the nature of this particular architecture, that it is definitely suited for complex application development, and if it is suited for complex development, definitely the complexity is going to be the higher side. And though we are saying that if we are implementing this particular 3-tier architecture model for development of application, we are having certain advantage that we can make modification in one layer without much effect to the other layer. But still maintenance is a major problem for this. For example, if you are having a distributed application, and in that distributed application you are having different databases, and your server has to interact with different databases with the different condition, then definitely it is a maintenance problem, and sometimes different level of maintenance which either comes into your corrective, defective or preventive maintenance, needs a very thorough understanding of each and every component involved in your application, and then only you can perform the operation. And network efficiency lower, you can say, definitely if you are working on a stand-alone machine, so network is not a problem at all. But if you are looking utilization of the network for communicating for a distributed application, then network efficiency also comes into existence while you are measuring the performance of the application. So sometimes you are looking for a higher bandwidth, or sometimes you are looking for faster communication, but due to the network speed availability or network efficiency, you are constrained with the another resource. And definitely incorporating more parts you have to include. Otherwise, if you are not incorporating more parts in your application, then your 3-tier architecture will not be properly implemented. So definitely you need some components to be purchased, bought and configured to manage the different aspects of the implementation. That aspect may be from the client side, that aspect may be from your server side to the database side. So this is another added disadvantage. But disadvantage, once again, if you are going to implement a very high complexity system, you have to have the resources, and this disadvantage is reflecting towards that side only, that if you are going to develop a very big setup and or a application which is going to work on the concept of distributed processing or on the concept of the web application 3-tier architecture processing, then definitely you must have to incorporate some more components. You have to buy some component to make communication feasible. So this is very basic requirement of this 3-tier architecture. Now N-tier architecture. This N-tier architecture you can take definitely just as a further extension of 3-tier architecture as per your requirement and the complexity. If you are distributing whole application component wise on different tier, then you can create a n-tier application, but generally 3-tier applications serve the purpose for even complex application development. And if you are developing one n-tier architecture, then you have to rely on different communication technologies, that is RMI, then you have to rely on different directory services, that is DNS, and then you have to Genie, JNDIs and some other advanced technologies available. And JDBC is definitely there, and JDBC is applicable for even 2-tier architecture, for 3-tier architecture and for n-tier architecture. Now if you talk about JDBC architecture, what you are having here is just, it is not visible. Let me change the color of this particular slide, because on this machine it is not very clearly applicable. So just I will try to give some more color. No, it is just 1 minute. Now it may be visible to you. So if we talk about JDBC architecture, our application is there, in that JDBC is there, and that JDBC is once again loading a driver, and that driver is interacting to database. So Java code calls JDBC library, java.sql, and then JDBC loads the driver. Driver talk to a particular database. Now if I say this is X database and this is the driver for this database, if I remove this particular database, what I have to remove? Have I to remove or modify my application? No. Have I to remove the JDBC component of our application? No. Then driver? Yes, definitely you have to remove this driver and put another driver which can interact to some other database which has been changed to. So only driver and database you have to take care, other part will be unchanged. So the very basic idea of JDBC is that you can change database engine without changing any application code. So this two vowels are showing you application codes, and this particular is the driver and this particular is the database. So you have to have a freedom in your JDBC, or JDBC provide you freedom that you can change the database, you have to change only driver accordingly. You don't have to change your JDBC application program developed for interacting to the database. Now if we talk about the category of drivers, so these drivers basically belong to 4 categories, and the type 1, type 2, type 3, type 4 are known as: type 1 is the bridge driver, type 2 is the native driver, and type 3 is the middleware driver, and type 4 is known as pure, this is pure Java driver. So let us see these drivers one by one. Now see, this is a very simple diagram that you are having JDBC. JDBC is trying to interact to the database. In between you are having driver. So if you are having type 1 bridge driver, you have to use this particular bridge driver. For example, you are having ODBC bridge driver, then you will put here ODBC bridge driver and you can interact. And if you are having type 2 native driver, then you have to put the driver libraries at appropriate places, and you have to properly set up different paths and other requirements so that these libraries are fully visible and while you are interacting to the database by using this particular driver in your JDBC program, you can interact. And similarly, type 3 driver, if you are having middleware driver and then you are having a server, and at both end you have to have some part of this driver so that it can interact to the database. Basically, if we are talking about type 3 driver, we are talking about network application or distributed application. And similarly, type 4 driver is also, so type 4 driver is not much more different than your type 3 driver. These two can be seen into the same category. The only difference is that type 3 drivers are generally implemented in other native programming languages, and type 4 driver is developed by using only Java programming language. So that's why type 4 driver is also known as pure Java driver. Now let us see these drivers one by one in more detail. Type 1 driver is basically used as a bridge driver, and it use bridging the technology. That means if some driver is already existing and you can create a DNS as we created in our previous lecture, so that particular DNS you can use for connecting the database. And definitely your bridge technology, or in our example ODBC, must be installed on your machine, and it should be configured on your machine. Then only you can create the data source, and that particular data source you can use for loading the driver and performing the connection. And it is not good for web application. If you are saying web application, one more tier is coming, that you will have a web server, and if you are having a web server, you have to communicate to the web server, and then web server will communicate to the database. So it is basically comes to a application in that you are trying to communicate from one machine to another machine. Though it may be that on a single machine you are implementing web application, but generally web application means that you are having a client, then you are having a server, and that server is taking the request of the client and performing the operation. And definitely if web server need interaction of the database, web server itself will go to the database. So web applications generally belong to 3-tier architecture application. So this type 1 driver don't suit for the web applications. And one of the example of your type 1 driver is that is JDBC ODBC bridge driver, and this is very popular driver, and for standalone applications it is used extensively. Type 2 drivers are native API drivers. These drivers requires their installation and configuration on the client machine, so that client machine can identify the driver and can load on the request of the JDBC application. And these are having one disadvantage, that these drivers are not thread safe. Means if you are trying to make multiple connection, it may create some kind of problem in your database inconsistency. Some example of this kind of driver is that Oracle driver, your WebLogic driver, MySQL driver, and some other database vendor driver. So basically this type 2 driver also works for your standalone machine, that you are having your application on the machine, you are having database on that machine, and you are having a driver installed properly and configured properly on the same machine. And when you are writing JDBC program, you are using this driver to interact to the database. Type 3 this type of driver basically used for client server application, or rather you can say distributed application. Means your application will require communication from one machine to another machine, means network is coming into existence. It is having flexibility that you have to allow access to multiple database using one driver, that on your client machine or on your application machine, suppose you have installed this particular driver, so this driver will interact to your application and it will communicate to the network layer. In turn, network layer will go to the database, and database once again will interact with the message, it will perform the operation, and again it will turn back to the driver, and then driver will respond back to your application. So if once this particular driver is downloaded, it can be used. For example, of type 3 driver, Symantec DBA, Anywhere, and these drivers are of type 3 driver. And type 4 drivers, as I mentioned earlier, that pure Java driver use Java networking libraries to talk to the directly to the database engine. So if I am saying here use Java based networking libraries, and before this I said that type 3 driver and type 4 driver can be seen in the same category. So the only difference between type 3 driver and type 4 driver is that what libraries that driver is using, or implementation of that driver is in some other language, or it is in Java language only. So if the implementation for network communication or data processing from one machine to another machine is with the help of the Java programming or Java network libraries only, then that driver will come into type 4. Otherwise, if it is using some other native programming language, then it will be of type 3. And as this particular is implemented in Java, so for each database its implementation will be different, and definitely JVM must be interacting to it. So you have to have this Java driver for different implementations separately. For example, for Oracle you will have different type 4 driver, for MSQL you will have different type 4 driver. And if you want to see a detailed list of different drivers available, you can visit this website, that is http://rd.business.com. This particular site is having a very extensive list of the different drivers available for JDBC. As I mentioned earlier also that java.sql is the basic API for JDBC programming, and this particular API or this particular package is used for performing the SQL related operations, that is performing the operations of your driver loading, performing the operation of your connection creation, performing the operation of your creating statements for different kind of SQL operations, and performing operation for execution of those statements. Now, how these drivers are loaded? As I mentioned earlier also in the previous discussion, that you have to load it. So you can create the driver D, and this driver you are loading by calling the driver class method. For example, if foo.bar is my driver and this particular method is for loading or creating this particular driver object D. So if D is created, you can create the connection, but this is not recommended. Generally what is recommended is that you have to use class for name and then this particular class name inside that, so that it can be verified whether this class is loaded or not, and if it is not loaded, object of this class is loaded or not, and if the object of this class is not loaded, it will be loaded at the time of checking of that particular loading process. See, this particular is very much useful, that if you know that this particular specific driver will be loaded, and if that specific knowledge is not there, in fact a checking process is there, and that through that checking process it is being checked that whether this driver is loaded or not. And if you are not sure that whether driver is loaded or not, this method of loading the driver is not recommended. If you are well sure that driver is not loaded, this particular method you can use, that you can create the driver object D, and D dot connection you can perform and you can get a connection. Driver manager, as I mentioned that there is a checking process, so your driver manager tries to all the drivers, or tries to check all the drivers one by one, and it try to match with the driver which you are looking for, and then use the first one that exactly match the requirement. And when the driver class is first loaded, it is registered, is set with the driver manager, and once it is registered with the driver manager, you can get the connection. Therefore, to register a driver, what you have to do is you just have to load the driver. And here you have seen two ways of loading the driver. One way of loading the driver is that you can create the object of that driver class, and with that created object you can call the connection method on that and you can get the connection. Otherwise you can use class and then for name method, and inside that method you can provide the class name with its proper hierarchy, and then it will be loaded. So these two are, this is the recommended way: class, for name, then the class name you have to give. And once you registered it, it is registered with your driver manager, and once your driver is registered with the driver manager, you can call the get connection method on that and you will get a connection. And once you have got the connection, on that connection you can perform the operation with your database with which you have connected. So you can summarize here for your JDBC ODBC classes that driver manager load and choose the driver. Driver class or driver interface basically provide a object. That particular object you can create by calling the constructor or calling the method of creation of the object of that driver. And then connection, definitely you can call either on this driver object or on the driver manager to get the connection. And statement is nothing but the SQL statement in your Java language, and you perform some operation on the basis of what kind of statement it is, whether it is DML or DDL, and on the basis of that you get the result in your result set, and result set provide you facility to visit one record to another record one by one. So this diagram gives some basic picture about how actually JDBC classes used for performing the JDBC application. You are having driver manager, or rather you can say your driver is now registered with the driver manager. So driver is available. If driver is available, on that you call the connection. If connection is available, you can perform the operation on the SQL statements, and once you perform the operation on SQL statements, you get the result set, and that result set gives your desired result. Now how actually you write your different URLs. So these URLs are nothing but each driver has its own separate sub-protocol associated with it, and each sub-protocol has its own syntax for performing the operation. For example, JDBC ODBC, this ABCD may vary. For example, JDBC ODBC, and then you write JDBC ODBC bridge, and another is JDBC, then MySQL, then you are having your database name, then you are having port number, and then you are having the actual database. As I mentioned earlier that once your driver is registered with the driver manager, you can get the connection. For getting connection, what you have to do is driver manager.getConnection you have to call, and in that what you pass as parameter is that your URL and username and password, and these username and password belong to individual user of that particular database, and in turn it execute and it give the connection object, and that connection object is used for performing the operations on SQL statements. As I mentioned in my previous session that you have to capture the exceptions properly, so these exceptions must be captured, or these statements must be written inside the try-catch block of Java. Connection, you can see connection as a session with the specific database. Means a connection is nothing but a establishment between your application and the database, and that establishment is seen as a particular session. Once the connection is closed, your session with the database or your interaction with the database is closed. Within the context of the connection, SQL statements are executed. So once you are connected, inside that context you create your SQL statement and execute those statements and get the result. And you can have multiple connection of your database, but there is a warning: all the database don't support multi-threading or not having capability to handle multiple connection. So creation of connection pool and managing that particular is altogether a different aspects of complex programming development, and that to be taken care properly. Otherwise, creating multiple connection and modifying same database without proper multi-threaded handling may turn up into inconsistent database. And your connection also provide metadata, and metadata is nothing but information about your database, and that information are sometimes very helpful for knowing what actual database is and why you are using this database, what is the version of database, what is the name of this database. Connection time and some other aspects also involved with the metadata may be obtained by using connection object. And as I mentioned in my previous session that transaction handling is very important, and transaction management is one of the most important process of any database programming. So for that also there are method, that is commit and rollback, and through those method you have to ensure that your transaction should not lead to a inconsistent transaction. If your transaction is leading towards a inconsistent transaction, or you are having a suspicion that it may turn up into some inconsistent database, you must have to check at appropriate level. You don't have to apply commit, you have to roll back to a position from where you can retrieve properly, from where you can restart the execution of different statement on the basis of your intermediate result. So that particular aspect is there, and these aspects are commit and rollback, and these must be implemented very intelligently while you are developing your application. As I mentioned earlier also that for obtaining connection, what you have to do is you have to register your driver, and once you have registered your driver, for example here class for name and then the class hierarchy of your driver. Once you get the connection, then you have to use driver manager get connection, then you have to pass the URL. This is your URL for the driver. This URL will have login and password also, and then you have to catch appropriate exceptions which are expected to be thrown, and once you get the connection, you are open for performing the operation and getting the result. So some connection methods let me see. create statement, and then prepare statement, and then callable statement. These all are the different type of statements that you can create, and these all are applicable at different kind of application. Definitely, whether it's belong to your dynamic execution or whether it belong to your static execution, on the basis of that you have to implement the application. For example, if your prepare statement is there, it is compiled once and it is ready for execution for different time. So you can take a prepared statement like a method. In that method, what you are exactly going to do is you are going to pass certain parameter, and on the basis of that parameter your prepare statement will be executed and it will give the result. Now if you ask what actually a statement is, so a statement is nothing but a specific SQL operation that you are going to perform. For example, if I say create table XYZ with certain parameters or with certain characteristics, then my statement is that I am going to create a table of such and such name with so and so attribute and so type. So similarly, other statements also may be there: insert into, delete, and some other, commit, rollback. These all are different statements associated with different SQL operations, and they are implemented at their appropriate level while developing the JDBC application. Now let me see some methods which are used for performing operation on these statements. Execute query. Execute query method is for performing the read operation, as we have seen earlier. Execute update. This particular is to execute the update operation. Now if I put one question, that what is the difference between execute query and execute update? So there will be a very straightforward answer, that in execute query we are expecting that some rows will be modified and those rows will be turned up as a result, but execute update will only give you the number of the updated rows or number of affected rows by this particular operation. Result set, as we have already seen, that result set provide the access to the table generated by executing the statement, and result set provide the facility to move one by one from one row to another row. But one more thing you have to take care, that once you have performed next operation on your result set object, then you can't rewind it. Means if you have visited one row of your result set, you can't go back and revisit that particular row again. So with this I can say that I tried to explore the basic possibilities of different kind of application development in this JDBC aspect, that what are the different architecture, that is 2-tier, 3-tier and n-tier architecture, what are the different drivers available in JDBC. We seen there are 4 type of driver. Type 1 is your bridge category, that is already existing technology driver and you are bridging to that. Another is a native driver that is available and that you have to load and register with your machine. And third one is a network APIs implemented in some other native programming language, and fourth one is pure Java APIs. By using core Java APIs, network application is developed for performing the different protocol operations to communicate from one machine to another machine in the distributed environment to communicate to the database. So with this we come to end of this session, and this will, I hope this will help you to develop JDBC applications. Thank you.